tell me, what is Jan? Jan is an operation. In Jan operation, what it will do? One table row will be joined with another table row based on Jan condition. This is called Jan. Why Jan? Why we are using Jan concept, sir? To retrieve data from multiple tables. If you want to get data from multiple tables, then go for this Jan's concept. There are four types of Jans are there. Four types of Jans are there. What are those? Inner Jan, outer Jan, self Jan, and cross Jan. Self Jan and cross Jan. Self Jan can be also called as recursive Jan. Cross Jan can be also called as Cartesian Jan. In the inner Jan, two subtypes are there. What are those? In the inner Jan, two subtypes are there. What are those? Equigen, non-equigen. In the outer Jan, three subtypes are there. What are those? Left outer Jan, right outer Jan, and full outer Jan. You tell me, what is inner Jan? Inner Jan gives what, sir? Match record, simple. One line statement. Inner Jan is equal to match records. What is outer Jan? Gives match records and unmatched records. What is left outer Jan? Gives match records unmatched from left table. What is right outer Jan? Match records unmatched from right table. Full outer Jan gives match records unmatched from left and right hands. That's it. What is equigen? Performs Jan operation. Equigen performs Jan operation based on equality condition. If Jan operation performed based on equality condition, that is equigen. Till here, very clearly we discussed in the previous two sessions. Now, I want to cover how to display unmatched records only. Outer Jan is giving both matched and unmatched, sir. Outer Jan is giving both a matched and unmatched, but I want to get only unmatched. How to get unmatched records only? Displaying unmatched records only. Three cases I will explain, sir. You already know left outer Jan. Left outer Jan gives matched records, unmatched records from left table. You already know this point. But what is our requirement? We want to get only unmatched. We don't want to get matched. So for this, we need to write one condition. We need to write one condition. So left outer Jan plus condition gives only unmatched records from left table. This case we need to discuss now. Next second case. Right outer Jan. Right outer Jan gives matched records, unmatched records from right table. This we already know. But we want to get only unmatched records. We don't want to get matched records. So for this, we need to write one condition. Right outer Jan plus condition gives only unmatched from right table. Next, last case. Full outer Jan. Full outer Jan gives both matched records, okay, and unmatched records from left and right tables. Gives matched records, unmatched records from left and right tables. This we already know. But we want to get only unmatched records. Only unmatched we want to get. We don't want to get matched records. So for this, write one condition here. Conditions we need to write. So because of conditions, it will not give matched records. It gives only unmatched records. These three cases we need to discuss now. That's it, sir. What is our requirement? Displaying only unmatched. Left outer join plus condition gives only unmatched from left table. Right outer join plus condition gives only unmatched from right table. Full outer join plus conditions give only unmatched from left and right tables. See, first example, left outer join plus condition. Pay attention, listen carefully. Suppose, first see left outer join. To that, I add one condition. Understand here? Question is, display employee details along with department details. Means he is asking match records here. So with this sentence, he is asking match records. And also display the employees to whom department is not assigned. Means employee is there, but to that employee, department is not assigned. Means from EMP table, he is asking unmatched records. Employee is there, but department is not assigned. See here. AB, employees are there. Department is not assigned. So these unmatched records he's asking. Okay. So with first sentence, so with first sentence, he is asking match records. Smith working in research department. Smith working in research department. Like this. Match record. With second sentence is asking that also display the employees to whom department is not assigned. AB employees are there. Department is not assigned. For these two records, there is no matching record available in department table. So he is asking unmatched records from EMP table. So I want to take EMP as the left table. I want to take EMP table as the left table. So from left table, I want to get unmatched records. So right left outer join now. Right left outer join. How to write left outer join? We already know. So right left outer join. Okay. So we want to get output like this. E name, D name. Smith working in research department. Match record. A. Employees there. Department is not assigned. Unmatched record from EMP. So we want to get this output. First record is match record. Second record is unmatched record from EMP. Take EMP as the left table. This is our requirement. So we need to write left outer join now. So write left outer join. How to write left outer join? We already know. How to write left outer join? We already know. Tell me, sir, how to write left outer join? You tell me Oracle style. How to write this left outer join, sir? Select A dot E name, D dot D name from MPE department D, where E dot department number equals to D dot department number plus. This is left order join. So it gives this match record and unmatched record. But what is our requirement? We want to get only unmatched. We don't want to get match records now. I don't want to get this Smith record. Match record I don't want. I want only unmatched record. What is the difference between this match record and unmatched record? Notice here. For unmatched record, department name is null. Observe. For matched record, department name is there. Smith working in research department. For matched record, department name is there. For unmatched record, department name is null. So if department name is null, display those records. So write condition as D dot D name is null. Left outer join plus condition. What is that condition? D dot D name is null. If I write this much only, it gives matched records, unmatched from left table EMP. My requirement is I want to get only unmatched. I don't want to get matched. So what is the difference between this matched record, unmatched record? We have to notice here. So for unmatched record, department name is null. So if department name is null, display. So write this condition only. D dot D name is null. Because of this condition, we get only unmatched record. We will not get matched record. So finally, we get only unmatched record from left table EMP. This is output we get. Left outer Jan plus condition gives only unmatched record from left table. This is Oracle style. Same query. Write in ANSI style now. Okay. Just to separate these two table names. To separate these two table names, use the keyword left Jan. For left outer Jan, use the keyword left Jan. Write this Jan condition in the on class. Don't write any plus here. Write this filter condition in the where class. That's it. Is our discussion correct or not? Login as our batch user. C ## batch 2 p.m. Password is Naresh IT. Okay, set page size. Set page size 200. Line size 200. Declare the script. Observe now. Just this first query I'm copying, sir. Left outer Jan. Okay, only left outer Jan I'm running. Observe. Only left outer Jan I'm running. Observe. See here. Left outer Jan is giving match records, 14 match records, and it is 2 unmatched records. So what is the difference between these match records and unmatched record? For unmatched records, department name is null. For unmatched records, department name is null here. So AB unmatched records, department name is null. So this condition only I'm adding now. Left outer Jan plus condition D dot D name is null. We are getting only unmatched records. Observe, sir. Only unmatched we are getting, see. So left outer Jan plus condition gives only unmatched records from left table. Next. Okay. Please confirm. Did you understand this case? Unnamed students, are you following? Is it clear about first case? Left outer Jan plus condition. Aman. Natural Jan means equi-Jan only. Equi-Jan is the natural Jan. Okay. Next. Right outer Jan plus condition. This case. This case I am explaining now. Right outer Jan plus condition gives only unmatched from right table. This case I am explaining. Understand now? The question is display the departments which are not having employees. Understand here? E name, D name. What is asking? Display the departments which are not having employees. See here. Operations department is there. 40 department is there. But 40 is not having any employee. This he is asking. Unmatched record from department table, right table he is asking. Only unmatched from right table he is asking. Operations department is there. Operations department is there. But it is not having any employee. See here, for example, how to get this result you already know. This first record is match record. first record is match record. Second record is unmatched record from department table. Take department table as the right table. So how to get this result you already know. Right outer join. Match records plus unmatched from right table means right outer join. How to write right outer join we already know. So write right outer join here. Select E dot E name, D dot D name from EMPE department D where E dot department number plus equals to D dot department. Department is right table. So from right table, we want to get unmatched records. So write right outer join. For right outer join, write plus symbol at left side. This is right outer join. Gives match records and unmatched from right table. This output we get. But what is the question here? Display only the departments which are not having employees. Means only unmatched we want to get. Matched I don't want. Match record I don't want. So we need to write condition. What is the difference between match record and unmatched record? Employee name is null. How to write this condition? E dot E name is null. Very good. That's it. This condition only we are writing. And E dot E name is null. So because of this condition, it will not give this match record. It gives only unmatched record from department table, right table. This is Oracle style. Same query. I want to write in ancestor. Okay, in ANSYS style, to separate these two table names, use the keyword right join. This join condition, write in on class, do write plus, write filter condition in where class. That's it. Copy this Oracle style. Observe now. First see right outer join. I'm running right outer join. Observe here, this is right outer join. Right outer join is giving match records, 14 match records, unmatched from right table department. So what is the difference between match record and unmatched record? Employee name is null. So write this condition only to get that unmatched record. And E dot E name is null. Because of this condition, I'm getting only unmatched record from department table. This department is not having any employee. Next, same query to write in ANSYS style. Right join. Okay, on E dot department number equals to D dot department number. Where E dot E name is null. Same output we are getting. Right outer join plus condition gives only unmatched record from right table department. This is getting only unmatched record from right table. Last one, sir. Full outer join plus conditions gives only unmatched from left and right tables. Full outer join plus conditions. Suppose the question is like this. Display the employee records to whom department is not assigned. Display the employee records to whom department is not assigned. Also, display the departments which are not having employees. I want to get two columns, E name, D name. Understand the question here. Display the employee records to whom department is not assigned. Employee is there, department not assigned. Unmatched record from EMP table, left table. Unmatched record from EMP table, left table. Next, also display the departments which are not having employees. Operations department is there, but it is not having any employee. So he's asking unmatched record from department table, right table. So we want to get unmatched records from left table and right tables. So how to write full outer join we already know. This is left outer join. This is left outer join. And this one is right outer join. This one is right outer join. In between left outer join and right outer join, we use the operator union. Yesterday we discussed this point. Union. So what this left outer join gives? Match records. Unmatched from left table EMP. What this right outer join gives? Match records. Unmatched from right table department. So what union is doing? Union is combining this result plus this result. Union never gives duplicates. So we get match records, unmatched from left table EMP, unmatched from right table department, full outer join. Yesterday we discussed it. But now what is our requirement? We don't want to get match records. We want to get only unmatched from left table EMP, only unmatched from right table department. So that is why I'm writing condition like this. So left outer join plus condition d dot d name is none. This first select query gives this record, unmatched record from EMP table. If d dot d name is null, it gives. And e dot e name is null. This is left outer join plus condition, sir. It gives only unmatched record from left table EMP. D dot D name is null. So this is first select query result. The second select query gives this result. E dot D name is null. So it gives unmatched record from department table, right table. So this first select query result is this one. Second select query result is this one. Both are combined. This first select query result, second select query result, both are combined by union. Union combines the rows. Union combines result of two select queries. This is first select query result. This is second select query result. Both are combined by union. That's it. This is full outer join plus conditions. Okay, this is Oracle style. Same query. I want to write in ANSI style. In ANSI style, no need to write this much complex query. Just to separate these two table names, use the keyword full join. Write this join condition in on class. Write filter conditions in where class. D dot D name is null. If department name is null, display or if E dot E name is null, display. That's it. Like this, right? Let me copy this first query. Observe. Notice here. This is first select query result. Observe, sir. First select query is giving unmatched records from EMP table. This is second select query. Second select query is giving unmatched record from department table, right table. Both results I want to combine. So I'm using union between these two select queries. So first select query result, second select query result combined by union. Observe here. This is first select query result. This is second select query result. Both are combined by union. Here, D dot D name is null. First select query result. Here, E dot E name is null. Second select query result. Both are combined by union. Full outer join plus conditions. This is full outer join plus conditions. Full outer join plus conditions gives only unmatched from left and right tables. Same query we are writing in ANSI style like this. Same output we get. But this is ANSI style. Full outer join plus conditions. Unmatched from left table, unmatched from right table. It's not giving match record. So now total 7 cases You know very clearly. What are those 7 cases? Observe here. I'm representing in the form of Venn diagrams. Observe. Venn diagrams of giants. See, this is left table EMP. And this is right table department. This is left table EMP. This is right table department. Total 7 cases you know now. This is first case, second case, third case, fourth case, remaining 3 cases, 7 cases. What are those 7 cases? First one, inner joint or equijoint. Second one, left outer joint. Third one, right outer joint. Next one, full outer joint. Next one, left outer joint plus condition. Left outer joint plus condition. Right outer joint plus condition. Next one, full outer joint plus conditions. So these are the 7 cases. Understand now? Inner joint gives match records only. This is inner joint. Gives only match records. Match records only. I'm representing like this. Left outer joint gives match records. Unmatched from left table EMP. Left outer joint. Observe. Match records. Unmatched from left table EMP. Right outer joint gives match records. Unmatched from right table department. Full outer joint gives match records. Unmatched from left table EMP. Unmatched from right table department. Left outer joint plus condition gives only unmatched from left table. Right outer joint plus condition gives only unmatched from right table. Full outer joint plus conditions gives only unmatched from left and right tables. This is about 7 cases. Is it clear about 7 cases, sir? So from previous 3 sessions, what we discussed means these 7 cases only. Online students, please confirm. Is it clear about all these 7 cases? If it is clear, we can move forward. Please, all of you confirm in the chat box. Fayaz Muhammad. When you are developing giant queries, follow ANSI style. ANSI style is the best way. But as a developer, sometimes we need to understand the queries which are written by others. Okay, that is why as a developer, we have to learn both. Sometimes we need to understand the queries which are written by others. Sometimes we need to work with the code which is developed by others. So that is why. So if any old projects are there, they may use Oracle style. If you don't know Oracle style, you cannot work with that project now. So that is why as a developer, learn both. But when you are developing queries, use ANSI style. Okay, both Oracle style and ANSI style combination, it works or not. You try it. If Oracle is giving output, you are right. Otherwise, you are wrong. You try it. I didn't try like that. Okay, you try it. If Oracle is giving output, you are right. Otherwise, you are wrong. Fires. Next. Next one. Now, in the types of giants, we know very clearly about equigiant and all outer giants. We know. Now, we are discussing about non-equigiant. What is this non-equigiant? Pay attention, listen carefully. Non-equigiant. You already know about equigiant. If Jan operation is performed based on equality condition, then it is called equijan. If Jan operation is performed based on equality condition, that is equijan. You already know in Jan operation, one table row will be joined with another table row. This is Jan operation. If this Jan operation performed based on equality condition, this is equijan. Okay, E dot department number is equals to D dot department number, equijan. S dot student ID is equals to student table SID equals to marks table SID, equijan. Student table course ID equals to course table course ID, equijan. If equality condition is used to perform Jan operation, that is equijan. What is non-equijan? If Jan operation is performed based on other than equality condition, based on other than equality condition. If Jan operation is performed based on other than equality condition, that is called non-equal. For example, this is first table row, joined with second table row, joined with this second table row based on greater than condition, non-equivalent. Greater than means other than equals to. Suppose Jan operation performed based on less than condition, non-equivalent. Suppose less than or equals to, non-equivalent. Greater than or equals to, non-equivalent. Not equals to, non-equivalent. Between and, non-equivalent. Like that. So if Jan operation is performed based on other than equality condition, that is non-equivalent. So we are writing like this. E dot department number equals to D dot department number, equivalent. E dot department number greater than D dot department number, non-equivalent. E dot department number less than D dot department number, non-equivalent. If we use other than equals to, non-equivalent. If we use equals to, equivalent. That's it. So see one example on non-equivalent here. One suitable example I'm telling. So equigen, very, very important. Most frequently we use equigen and outer gen. Non-equigen, not that much important. Non-equigen, not that much important. One suitable example I am explaining. Understand now. For example, this is EMP table. It has employee details like this. This is salary grade table. It has salary grades. If employee salary is between 700 to 1200, first grade, like this salary grades are there. If employee salary between 700 to 1200, that salary grade is 1. If salary is between 1201 to 1400, second grade. If salary is between 1401 to 2000, third grade. If salary is between 2001 to 3000, fourth grade. If salary is between 3001 to maximum any number you can take. I'm taking maximum 9999, fifth grade. Like this salary grade table has salary grades. Understand now? This first employee salary 2500. Second employee salary 1300. Next employee salary 5000. Like this data is there. Now, I'm asking simple question, sir. You tell me, what is the salary grade? What is the salary grade of A employee? What is the salary grade of A employee? What is the salary grade of A employee? How you are telling? This A salary 2500 falls between this range or not? That is why you're telling 4. Same thing Oracle has to do. For EMP table, I'm giving alias name as E. For salary grade table, alias name is S. Okay, if this employee salary falls between this low salary and high salary, then join them. Yeah, that's it. Just now I asked one simple question. Once again, I am telling. Just now I asked one simple question. What is the salary grade of A? I asked. What is the salary grade of A? Then immediately you told 4. How you told? Because A salary is 2500. It is falling between 2500 is falling between 2001 and 3000. So employee salary falling between this range. So that is why you told salary grade is 4. Same thing Oracle has to do. If employee salary falls between this low salary and high salary, then join them. If we join like this, we can access grades now. So the question is, display employee details along with salary grades is a question. So I want to get output like this. Employee name, salary is grade. I want. Notice here, e-name salary columns are available in EMP table. This grade column available in sal grade table. So from 2 tables, we want to get the data. So from 2 tables, we want to get the data. If we want to get data from multiple tables, definitely we have to go for joins. Okay, so write like this. Select. What we want to select? E dot ename, E dot salary, S dot grade. From which tables we want to get? EMPE, comma, salary grade S. Where? Write Jan condition now. What is the Jan condition? If employee salary falls between this range, join them. So how to access employee salary? E dot salary. E dot salary. To compare with range of values, we use the operator between. Between. What is the lowest value? S dot low salary. How to access this 2001? S dot low salary. How to access this high salary? S dot high salary. S dot high salary. That's it. This is Jan condition, sir. This Jan condition is other than equals to observe. Jan condition is between and condition now. Means non-equivalent. This is non-equivalent. You tell me the query, sir. Oracle style. How to write? Select E dot ename, E dot salary, S dot grade from EMPE, sal grade S. Where? Right? Jan condition. Okay. What is the Jan condition here? Observe. Just now I asked this question. What is the salary grade of A? You told 4. How you told? Employee salary falls between that low salary 2001 and high salary 3000. This employee salary falls between this range. If employee salary falls between that low salary and high salary, join them. E dot salary 2500, low salary 2001, high salary 3000. If this employee salary falls between this range, join them. This is join condition. This is join condition. That's it. This is Oracle style. So how it is performing join operation? Observe here. First employee salary 2500. E dot salary. E dot salary 2500. Is it falling between 700 and 1200? It is checking. S dot low salary value 700. S dot high salary value 1200. Is 2500 falling between 700 and 1200? Is it falling between 1201 and 1400? False. Is it falling between 1401 and 2000? False. Is it falling between 2001 and 3000? True. 2500 falling between 2001 and 3000. True. So it performs join operation. 1001 record joined with fourth grade like this. Next is 2500 falls between 3001 and 9999. False. Next value 1300. Is 1300 falls between 700 and 1200? False. Is it falls between 1201 and 1400? True. Remaining false. So it joins like this. 1002 record joined with second grade. Like this it joins. Next employee salary 5000. Is 5000 falls between 700 and 1200? False. 1201 and 1400 false. 1401 and 2000 false. 2001 and 3000 false. 3001 and 9999 true. So this record will be joined with fifth grade like this. Like this, it performs join operation based on between and condition, based on other than equality condition. That is why it is called non-equijoin. So this is Oracle style. And this is ANSI style. I already told non-equijoin also inner join only. Non-equijoin also inner join only. So use the keyword inner join. Write this join condition in the on class. That's it. This is Oracle style query. This is ANSI style query. Here, sal grade table is not ready. Select star from sal grade. Sal grade table is not ready. Observe, there is no sal grade table. Create it. I already provided this sample tables file to you. Okay. I already provided this file to you, sir. Here EMP table creation queries are there. Below of that, department table creation queries are there. Below of that, sal grade table creation queries are there. So this is sal grade table creation query. We are inserting these records into sal grade table. Next, I'm copying these queries at SQL command prompt. Commit. Open and see the table data. Select star from sal. Notice here, if salary falls between 700 to 1200 first grade, 1201 to 1400 second grade, 1401 to 2000 third grade, 2001 to 3000 fourth grade, 3001 to 9999 fifth grade. This is our EMP table data. Select ename comma salary from EMP. Observe. So these salaries are first grade, 1201 to 1400 second grade, 1401 to 2000 third grade. Like this, we want to get the output. 2001 to 3000 fourth grade. Next, fifth grade. Like this. Salary grades we want. So we want to get e name salary, and grade. E-name salary columns available in EMP table. Grade column available in sal grade table. Tell me the final query, sir. Oracle style. What we need to write? Where? What is the condition? Uh, between. That's it. So whenever you are writing this condition, this should strike in your mind. E dot salary falls between low salary and high salary. Jan the is the Jan condition. Oracle style I am writing. Observe here. Employee details with salary grades you are getting. Observe. See 700 to 1200 first grade. 1201 to 1400 second grade. 1401 to 2000 third grade. 2001 to 3000 fourth grade. 3001 to 9999 fifth grade. Employee details with salary grades we are getting. So here, other than equality condition I am using to perform this Jan operation. So this is called non-equivalent Oracle style. Same query I want to write in ANSI style. To separate these two table names, use the keyword inner Jan. Shortly you can write join. Write this Jan condition in the on class. Same output I am getting. Employee details with salary grades. But this is ANSI style. This is about non-equivalent. Non-equivalent topic is over. So finally, the conclusion is inner Jan gives match records only. Equijan means it performs Jan operation. If Jan operation is performed based on equality condition, that is equijan. Non-equijan means it performs Jan operation based on other than equality condition. If Jan operation performed based on equality condition, equijan. If Jan operation performed based on other than equality condition, non-equivalent. Outer Jan gives both matched records and unmatched records. Left outer Jan gives matched records unmatched from left table. Right outer Jan gives matched records unmatched from right table. Full outer Jan gives matched records unmatched from both left and right tables. If we want to get only unmatched, left outer Jan plus condition gives only unmatched from left. Right outer Jan plus condition gives only unmatched from right. Full outer Jan plus conditions gives only unmatched from left and right. All inner Jans and outer Jans are over. Is it clear up to here? Next one is self Jan. If you don't listen, you cannot understand this. Pay attention, listen carefully. We are discussing about self Jan. If you don't listen, you cannot understand this. Listen carefully. It can be also called as recursive Jan. Till now, we joined one table row with another table row, sir. Till now, in inner Jan and outer Jan, we joined one table row with another table row. This is table A. This is table B. Till now, we joined one table row with another table row. But in self Jan, there is only one table will be there. In self Jan, there is only one table. In self Jan, one table row will be joined with another row in the same table. This is called what, sir? Self-gen. This is self-gen, simple. Once again, I am telling, listen. Till now we joined two tables. This is table A row. This is table B row. Table A row we joined with table B row. One table row we joined with another table row. Till now we joined like this. But in self join, there is only one table will be there. There is no second table here. There is only one table. In self join, what happens? One table row, one table row will be joined with another, will be joined with another row in the same table. One table row joined with another row in the same table. This is called what, sir? Self. Self join. A table is joined to itself. Table A row joined with another row in the table A. If a table is joined to itself, this is called self join, or you can say recursive join. Okay. If a table is joined to itself, then it is called self join. If a table is joined to itself, then it is called self join. So in self join, one table row in self join, one table row will be joined with another row in same table. One table row will be joined with another row in the same table. That is why it is called self join. In self join, only one table will be there. That table will be joined to that table only. Till now we joined like this. EMP table we joined with department table like this. Okay, student table we joined with marks table like this. Till now we joined like this. EMP table row we joined with department table. Student table row we joined with marks table row like this. But in self join, one table row will be joined with another row in the same table. So same table name we write for two times. If a table is joined to itself, this is called what, sir? Self join. Here EMP table row joined with department table. A student table row joined with marks table row. But here EMP table row joined with another row in the same EMP table. EMP table joined to itself. EMP table joined with EMP table only. This is called what, sir? Self join. In self join, we write same table name for two times. Same table name two times we are writing means understand that is what? Self join. See one suitable example on it. And this is interview question also. Example on self join. The question is like this. So first see the table data. This EMP table. It has data like this. Employee ID, e-name, his job, salary, and manager ID. Manager ID. Understand now? This employee, A employee working as manager. So he is manager. He is not reporting to anyone. So manager ID is null. 1002 B employee. He is working as clerk under the manager 1001. 1003 employee working as salesman under the manager 1001. This 1004D employee, he is working as manager is not reporting to anyone. This 1005 employee working as clerk under the manager. Under the manager 1004. Like this data is there, sir. Now the question is display employee details along with along with manager's details. This is a question. I want to get output like this. Employee name, that employee salary, manager name, that manager's salary. This is my requirement now. I want to get employee details with manager's details. Now you tell me, what is the manager name? What is the manager name of B employee, sir? What is the manager name of B? For B employee, who is the manager, sir? What is his manager name? A. How you are telling? This manager ID is equals to employee number. That is why you guessed that for B employee, A is the manager. Same thing Oracle has to do now. Just apply the common sense. Just now I asked this question. What is the manager name of B? I asked. Then immediately he told A. Have you told? Based on this manager ID. Manager ID is 1001. So 1001 means A. That is why you told A is the manager name. Same thing Oracle has to do now. What Oracle has to do? If manager ID is equals to employee ID, then join them. So join employee record with is manager record like this. Observe here, EMP table row, EMP table B row, joined with EMP table A row. Employee row, joined with manager row. So this is called what, sir? Self-join. Are you understanding? Okay, once again I'm telling. Just now I asked this question. What is the manager name of B? I asked. Immediately told A. Have you told this manager ID 1001? This employee number 100. If manager ID is equals to employee number, then join them. So 1002 B record, join with is manager record 1001. So here EMP table row joined with another row in the same EMP table. So this is called self join. If one table row joined with another row in the same table, this is self join. So I want to get output like this. Employee name, employee salary. Manager name, manager salary. So employee name is B. B. His salary is 10,000. His salary is 10,000. For B employee, manager is 1001. Means A. Manager name is A. Manager salary is 40,000. This is the output I want to get, sir. This is my requirement. So if you want to get output like this, write like this now. Understand now. So we cannot write like this, sir. Observe this B employee name. So I'm writing like this. Select employee name. Ename. B. Employee name. Ename. Okay. Next. Employee salary. Employee salary. 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 Next, manager name A I want to get. Manager name A means ename column value only. Manager salary 40,000 salary from EMP. If we write like this, what happens, you know? We get output like this. Okay. Employee name B. Salary 10,000. Again employee name B. Again employee salary 10,000. So that employee record only we are getting 2 times here. Same employee record we are getting. This output we get. But this is not our requirement. We want to get employee details along with manager details. Here I want to get manager record. So I cannot write like this now. If I write like this, same record I get 2 times, sir. B 10,000, B 10,000. Like. But what I want to get? Employee details with manager details. So if you write like this is normal query. This is not giant query. This is normal query. This is not giant query. So generally giant happens between two. Till now we have written like this, EMP comma department like this. But here two tables are not there, only one table is there. But if I write like this, if I write one table name like this, Oracle is understanding this as normal query. Same data I am getting for 2 times. Like this. Oracle is understanding this as the normal query. So that is why for Oracle understanding purpose, so here we are tried same table name for 2 times. Same table name we are writing 2 times means this is self-gen EMP table joined with EMP table only. If I write like this EMP comma department, EMP table joined with department table. But what I'm writing here, EMP comma EMP. EMP table joined with EMP table only. If we write same table name 2 times, this is self-gen. So because of we are retrieving data from one table, we cannot write like this. If you write like this, same record you get for 2 times. Oracle is understanding this as the normal query. Oracle is not understanding this as the giant query. So for Oracle understanding purpose, we write same table name for 2 times. Because of I'm writing same table name for 2 times, don't feel like there are two EMP tables. There is physically only one EMP table is there. Logically, we are taking that as 2 tables. So this is first EMP table. And this is second EMP table. Second EMP table. For first EMP table, I'm giving alias name as E. Understand like employee details. For second EMP table, I'm giving alias name as M. Understand like manager's details. Okay, understand now. Just now I asked this question. What is the manager name of B? Then you told A. How you told? This manager ID and employee number both are equal. That is why you guessed A is the manager. Now same thing Oracle has to do. If this manager ID, E table manager ID is equals to M table employee number, join them. B employee record, join with this manager record. Like this we have to perform join operation. Now observe now how to access this employee name. E.ename. E.ename. How to access this employee salary? E.salary. How to access this manager name? M.ename. How to access this manager salary? M.salary. Right like this. E means understand like employee details. M means understand like manager details. What is the giant condition here? E.mgr equals to M.employee. Why we are writing this giant condition only? Because just now I asked this question for B, who is the manager I asked? Immediately he told A. How you told? This manager ID equals to employee number. Same thing Oracle has to do. If E table manager ID equals to M table employee number, join them. Employee record, we are joining with manager record. How to access employee name? E.ename. How to access employee salary? E.salary. How to access manager name? M.ename. How to access manager salary? M.salary. So write like this. Select E.ename as employee name. E.salary as employee salary. M.ename as manager name. M.salary as manager salary. From EMP EMP where Jan condition E dot MGR equals to M dot employee number. If E table manager ID is equals to M table employee number, then Jan them. Why we are reading this Jan condition only? Because you only told for B employee, A is the manager you told. If this manager ID equals to employee number, Jan them. That is why we are reading this condition. How it is performing Jan operation? Observe now. First manager ID null. So it will not join with any record here. Leave it. Next manager ID 1001. E dot MGR 1001. Is 1001 equals to 1001? True. This B record will be joined with A record like this. Next, is 1001 equals to 1002? False. Is it equals to 1003? False. Is it equals to 1004? False. 1005? False. So it will not join. Next, again 1001 equals to 1001. So C record will be joined with A record. Employee record joining with manager records are observed based on this condition. Is 1001 equals to 1002? False, 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 false. 4 false. Next, null, leave it. Next one, 1004. Is 1004 equals to 1001? False. 1002 false. 1003 false. 1004 true. So this employee record will be, this E employee record will be joined with 1004D record like this. So employee record joined with his manager. Now write the final query now. How to access employee name? How to access employee name? E dot E name as employee name. How to access this employee salary 10,000? E dot salary. E dot salary as employee salary. Next, manager name. How to access this manager name? M dot E name. M dot E name. M dot E name as manager name. Next, manager salary. M dot salary. M dot salary as manager salary. From which tables we are retrieving? EMP E, EMP M. So because of I am writing EMP table for 2 times, don't think that there are 2 EMP tables. There is physically only 1 EMP table is there. Logically, we are taking that as 2 tables. For first EMP alias name E, for second EMP alias name M. E means understand like employee details. M means understand like manager's details. Where? Right, Jan condition. This is Jan condition. E dot MGR equals to M dot employee number. That's it. This is the query. This is Oracle style query. So if we are writing same table name for 2 times like this, understand this is self Jan. EMP table joined with EMP table only. Self Jan. Oracle style. Same query. I want to write in ANSI style. In ANSI style, to separate these 2 table names, we have to use keyword here. Tell me, sir, which keyword we have to write for self Jan? Which keyword we have to write for self Jan? Listen. Is it equality condition or not? Here, Jan condition. Equality condition or not? Equality condition means is it equijan or not? Equijan means inner jan or not? Not. So that is why this is inner jan only. This is equality condition, sir. Equality condition means inner jan. So that is why use the keyword inner jan. For self jan, there is no separate keyword. For self jan, there is no separate keyword. So because of this is equality condition, equijan means inner jan. So use the keyword inner jan. Write Jan condition in the on class. That's it, sir. This is Oracle style query. This is ANSI style query. This is very, very important query for interview. If interviewer wants to test your knowledge on if interviewer wants to test your knowledge on self-gen, most of the interviewers ask this question, sir. Display employee details with manager details. Employee details available in EMP table only. Manager details are also available in EMP table only. So employee record join with manager record. EMP table row join with EMP table row. Self-gen. Observe our EMP table data. Notice here. Employee number, e-name, salary, manager ID from EMP. Notice the data, sir. See here. Understand now? This fourth column name is MGR, sir. MGR means manager ID. Employee number, e-name, salary, manager ID. Okay. Observe now. For 7369 Smith employee, who is the manager? 7902 is the manager. 7902 means who is the manager? Ford. Ford is the manager. So if this manager ID is equals to this employee number, join them. So 7369 Smith record, we are joining with his manager record 4. If we join like this, we can access manager details now. This join we want to perform. Employee record available in EMP table only. Manager record also available in the same table, self join. For Smith employee, manager is Ford. So Smith record join with his manager record Ford. One more example. For 7499, Allen, 7698 is the manager. Means Blake is the manager. So join this Allen record. Join this Allen record with his manager record, Blake, like this. If we join like this, we can access this manager data. This is our requirement now. So we want to get employee name, employee salary, manager name, manager salary. There is only one EMP table is there, but logically we are taking that as two tables, EMP E, EMP M. So write like this, E dot E name, E dot salary. E dot E name as employee name, E dot salary as employee salary. M dot E name as manager name, M dot salary as manager salary. From EMP E, EMP M. Okay. Jan condition is if E table manager ID equals to M table employee number, Jan is the Jan condition. Tell me the final query, sir. How to get employee details with manager details? Oracle style. What we have tried? E dot E name as employee name, employee salary. E dot salary as employee salary. E means employee details, sir. M means manager details. I want to get manager name. M dot E name as manager name. Manager salary. M dot salary as manager salary. From EMP E, comma, EMP M. Where? What is the giant condition? E dot MGR equals to M dot employee number. This should strike in your mind. This one. E dot MGR equals to M dot M. If manager ID equals to employee number, then join them. Employee record, we are joining with manager record. That's it. So we get employee details with manager details. Observe here, just now we checked that for Smith employee Ford is the manager. For Allen Blake is the manager. Observe. We are getting employee details with manager details. Just now we checked here. For 7369 Smith, 7902 Ford is the manager. For 7499 Allen, 7698 Blake is the manager. For Smith, Ford is the manager. For Allen, Blake is the manager. Observe. For Allen, Blake is the manager. For Smith, Ford is the manager. Employee details with manager details we are getting. So this is about self. Same query I want to write in ANSI style. So in ANSI style, write like this. To separate these two table names, use the keyword inner join on E dot mgr equals to m dot employee number. Because of this is equality condition, equigen. Equigen means inner join. That's why I'm using inner join keyword only. For Smith, Ford is the manager. For Allen, Blake is the man. We are getting employee details with manager details. That's it. So this is example on self-join. Okay. Please confirm, sir. Did you understand this example? Okay. Girls, did you understand? Ardhamaindamma? Online students, please confirm. Is it clear about self-join? Suppose the question is like this. This is also interview question. Display the employee records who are earning more than their manager. Understanding question is very important here. Display the employee records who are earning more than manager. Observe here. Just now we have written this query. Employee name, employee salary, manager name, manager salary. Okay. Now you tell me, for example, this A employee salary 15,000. His manager is B. For example, I'm taking like this. Okay. It may not match with our previous EMP table data. Okay. So for example, A is the employee, his salary 15,000. To the A employee, B is the manager. For A employee, B is the manager, his salary is 40,000. Now you tell me, is this employee earning more than his manager, sir? No. We don't want to get it. For example, this C employee salary is 20,000. His manager salary is 18,000. Now, is this employee earning more than his manager salary, sir? Yes, this we want to. This is our requirement. So, how to get employee salary, you already know. E dot salary. How to get manager salary, also you know. M dot salary. If E dot salary value is greater than M dot salary, display. Simple. In previous query, we accessed employee salary. How to access employee salary? E dot salary. How to access this manager salary? M dot salary. What's the question here? If employee salary is greater than, display the employee records who are earning more than their manager. If employee salary greater than manager salary, display. So this is the condition we have to write. Previous self-join query, write with this condition. E dot salary greater than M dot salary. Observe now. See here. This is employee salary, sir. Scott employee salary 3,000. Is manager Jones, manager salary 2,975. Okay, is this employee earning more than his manager, sir? Is this employee earning more than his manager? Yes. Display it. This employee salary 3,000. His manager salary 2,975. This employee also earning more than his manager. Display. Here employee salary 1,600. His manager salary 2,850. Is employee earning more than his manager? No. Don't display. So Scott and Ford are earning more than their manager. But Allen is not earning more than his manager. So the employees who are earning more than their manager, we want. So I want to get, say, employee name, employee salary, manager name, manager salary. These employee names are available in the EMP table E. Manager details are available in the EMP table M. We don't want to get all employee records who are earning more than their manager we want. Tell me the final query, sir. What we write? E dot in name as employee name. How to get employee salary? E dot salary as employee salary. How to get manager name? M dot e name. M dot e name as manager name. Manager salary. M dot salary as manager salary. From EMPE, comma EMPM. Where? Jan condition. E dot MGR equals to M dot M. If I write this much only, I get all employee details with manager details. But I want to get who are earning more than manager. So write this condition. If employee salary greater than manager salary, display E dot salary greater than M dot salary, display. So the employees who are earning more than their manager, we are getting, observe sir, employee salary is greater than manager salary. Employee salary is greater than manager salary. That is why we are getting these two records. These two employees are earning more than their manager. Same query I want to write in ANSI style. Write like this. To separate these two tables, use the keyword inner join, or shortly you can write join. Write this join condition in the on clause. Write this filter condition in the where class. Same output we are getting, but this is ANSI style. So same table name we are writing two times means understand this is self join. Self join plus condition. Because of this condition, the employees who are earning more than their manager we are getting. So this is self join plus condition. Next. Last example on self join, sir. With this self join topic will be finished. Understand now. Suppose ICC, International Cricket Council, they want to conduct T20 World Cup. They want to conduct T20 World Cup. So they divided teams into groups. Group A, Group B, Group C, Group D, like this. Group A countries are India, okay, USA, and Canada, like this. This is a Group A table. Now, ICC wants to schedule the matches now. How they want to schedule? Each team in the Group A should play with the remaining two teams in the Group A. Like this, they want to schedule. This is our requirement. So we want to get output like this. India versus USA. India matches scheduled with remaining two countries. India versus Canada. So what we have to do? India record Jan with USA. You get India versus USA. India record Jan with Canada. You get India versus Canada. So group A table record Jan with another record in the same group A. Self Jan. India record Jan with Canada record. Group A record Jan with another record in the same group A. Self Jan. Then USA record Jan with Canada. We get USA versus Canada. All matches scheduled. Observe, sir. India matches scheduled with USA and Canada. Canada matches scheduled with India and USA. USA matches scheduled with India and Canada. All matches scheduled. Observe. This is the output we want to get. This is our requirement. So if you want to get output like this, we need to go for self-gen. But for self-gen, we cannot write like this. From group A, if we write like this, it is normal query now. So for self-gen, same table name, we write for two times. So physically there is only one group A table. Logically we are taking that as two tables. For first table I am giving alias name A. For second table I am giving alias name A. Group A, group A, B. So how to get this India? A dot C name. How to get USA? B dot C name. So this one only I'm writing. Select A dot C name concatenation operator versus B dot C name. B dot C. How to access this India? A dot C name versus we want to get this versus, sir, typing mistake, versus USA. How to access USA? B dot C. From which tables we are retrieving? Group A, comma group A, B. Where write Jan condition. Now we need to think about Jan condition now. Understand now? India record Jan with USA. India record Jan with USA. India record Jan with Canada. We need to think about the Jan condition now. So India country ID is 10. US country ID is 20. And Canada country ID is 30. So our India country ID is less than US country ID and Canada country ID. So if India country ID is less than US country ID, join them. If India country ID is less than Canada country ID, join them. So how to access this 10? A.CID. How to access this 20? B.CID. So Jan condition is A.CID less than B.CID. That's it. This is the Jan condition. Once again, I'm telling, listen. ICC, International Cricket Council, wants to schedule international cricket matches. So they want to conduct T20 World Cup matches. So they divided teams into Group A, Group B, like that. So they want to schedule the matches. Group A team. These are the Group A teams. Each team in the Group A should play with remaining two teams in the Group A. They want to schedule like this. So India match is scheduled with USA and Canada. USA match is scheduled with India and Canada. Canada match is scheduled with India and USA. This is our requirement. So India record, Jan with USA record. India record, Jan with Canada record. And USA record, Jan with Canada record. Like this, we want to join them. So self Jan. But we cannot write like this. We cannot write like this. If you write like this, Oracle understands normal query. That is why for self Jan, same table name we are writing for 2 times. So physically there is one group A table. Logically we are taking that as 2 table. Now schedule the matches now. India record Jan with USA. India record Jan with Canada. Think about the logic. India country ID 10. USA country ID 20. Canada country ID 30. India country ID is less than USA country ID and Canada country ID. So how to access India country ID? A.CID. How to access this US country ID? B.CID. So Jan condition is if A.CID is less than B.CID, then Jan. Understand now how it performs Jan operation? Observe. A.CID 10. Is it less than 10? False. Will not. Is it less than 20? True. So India record will be joined with US. India record joined with US. Next, A.CID 10. B.CID 30. Is 10 less than 30? True. India record joined with Canada. So now we get India versus USA, India versus Canada. Next, 20. Next one is 20, sir. Is 20 less than 10? False. Is 20 less than 20? False. Is 20 less than 30? True. Join them. 20 record joined with 30. So what we get now? USA versus this week. All matches scheduled here. Is 30 less than 10? False. Is 30 less than 20? False. Is 30 less than 30? False. Will not check. So finally, we get output like this. So Jan condition is A.CID less than B.CID. So this is self-Jan Oracle style. Same query. If you want to write in ANSI style, to separate those two table names, use the keyword. This is less than. Less than means non-equivalent. Less than means other than equals to. Other than equals to means non-equivalent. This is self-gen, non-equivalent. Previous example, self-gen, equivalent. This is non-equivalent. Non-equivalent also inner gen only. So that is why use the keyword inner gen. So previous example, self-gen, equivalent. This is self-gen, non-equivalent. That's it. This is Oracle style. This is ANSI style. Table is not ready. Let me create this group A table here. Create table group A. Country ID. Country ID. Number of 2. Country name. Care of 3. Insert the records. Insert into group A. Values. 10 India. 20 USA. 30 Canada. To save this, right? Commit. This is group A table data. Now we want to schedule the matches now. So India record Jan with USA, India record Jan with Canada, USA record Jan with Canada, like this. So this is our requirement. So we want to get output like this. So to get output like this, write the query now. How to access India? A.CNAME. How to access USA? B.CNAME. That one only I'm writing. Select A.CNAME versus concatenated with versus B.CNAME. B.CNAME. From which tables we are retrieving? Group A. Group B, Group A, B. Where? Right, Jan condition. What is the Jan condition? Just now we discussed the Jan condition. A.CID less than B.CID. A.CID less than B.CID. Even if you write greater than, same output we get, sir. You can write greater than also, same output we get. Okay, observe. As per our discussion, we are getting the output. India matches scheduled with USA and Canada. Canada matches scheduled with India and USA. USA matches scheduled with India and Canada. All matches scheduled here. So this is another example on self-gen. To get clarity on self-gen, one more example I have given. This is Oracle style. Same query I want to write in ANSI style. So because of that is less than condition, non-equigen means inner gen. Write this gen condition in the on class. Same output we are getting. Observe. But this is ANSI style. So same table name by writing 2 times means. So group A table Jan to itself. This is called self Jan. If a table is Jan to itself, that is self Jan. Group A table record Janned with another record in the same group A table, self Jan. So successfully we finished self Jan topic. Self Jan topic is over. Is it clear about self Jan, sir? Is it okay? So in the notes, very clearly I mentioned all these points, sir. Refer the notes and practice them. And some assignments may be there. Okay, refer them and try them. So now all types of joins are over except cross join. Now you know all inner joins, outer join you know, and self join also you know. Next we need to discuss about cross join. Because of time is over, I'm stopping the session here.